Of course it isn't. Of course. Why would it be? Anyway, hey, remember when I was telling you about like what to write to start off some notes? This is probably all we really need for today. And by the way, get ready for a big switch of gears. We're doing something completely different than yesterday, unrelated, completely and totally. And unfortunately, that does happen in our AP curriculum. I told you about that. Our last test, I really hated it. And I really tried to rearrange what we did last year to try to make it more cohesive. And it was still a little bit weird. There was too many different subjects in there. Graphing, solving, not really related to graphing, although you can make connections, blah, 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 blah. So anyway, just get used to that. This is all I really need to know, though. Circ or ticks and the flip. And then, you know what, though? I'm going to do something, even though this is written. And this is also why I'm mad. I just gave my second hour a little tongue lashing because of the homework again, and just we're not changing, blah, blah, blah. And then when I tell you to write things down, like when I do a quiz, don't I tell you to get out a piece of paper, right? This is another thing that's mind numbing. How many people don't get out a piece of paper? How many people don't write down what I tell them to write? That means you just accept your failure. And I can't sit here and be a witness to it. I can't. So when we do what we did yesterday, this is what we should write. And go ahead and write this down. This is not for today, but it's something by seventh hour. Remember I told you about, hey, draw a triangle. 30, 60, 90, 1, root 3, 2, 45, 45, 90, 1, 1, root 2. I'm done with that. I think we need to focus in and take a lane. I don't know why that pen's not working. I'm actually getting nervous. When my pen doesn't work like that, then it means a computer error might be coming up. That I lose this video. Hopefully that's not the case. I do want to move this down here. And then I know, well, I'm not going to say anything, but I'll mention what's kind of floating around in my head right now. Remember, this is coordinate trig. And then remember that this x coordinate is longer than this y coordinate. So therefore, this is the root 3 over 2 comma 1 half coordinate. And I can't help you if you don't know those two coordinates. This has been 4 months now. We're now into April that we've been talking about cosine and sine. Getting ready for that drink? About that time. Root 3 over 2 and 1 half. That's those are values for sine and cosine. These are equal from there to there. So that's the root 2 over 2 comma root 2 over 2 ratios. And then this one, the x is shorter than the y. So that flip-flops the root 3 over 2 and the 1 half to 1 half comma root 3 over 2. One more thing I might produce on this thing is these coordinates. And then didn't I do this yesterday, like quite a bit? Didn't I write these down yesterday when we had our quizzes for the unit circle? Yes or no? All right, and then this is how it works. This is how it works. What are all of these coordinates? Cosine comma sine or sine comma cosine? If you don't know that, you're severely and totally behind. What's the answer? Cosine comma sine. So all of these coordinates are in the form cosine comma sine. And then I'm not writing this down. We should know this first one's 30 degrees or pi over 6. The next one's pi over 4, and this one is pi over 3, the 60. And then you should know pi over 2 and then all the other things. If you want to, and again, I'm blabbering about this. This still only took me like a minute to write, maybe 2. If you really hunker down before you take a test, you write this stuff down and it should take you less than 30 seconds. And then you use it the rest of the way to evaluate the unit circle. So Wyatt, who got picked first? What's the cosine of 60 degrees? What's the cosine of pi over 3? But we could actually look at this. I see you looking up in the air right now trying to think about it. What's the cosine of 60 degrees? What? 1 half. What's the sine of 60 degrees? Root 3 over 2. What's the tangent? Now, I am going to go up to here. We should already know this. Tangent is sine over cosine, right? We know that before. So here's sine over cosine. So what's the, you didn't look when I highlighted that. What's the sine, what's the tangent of 60 degrees? Sine over cosine. Root 3. What happens to the 2's if I did root 3 over 2 over 1 half? They cancel. So all of these, I should be able to do tangent as well. Root 2 over root 2. What is that, Wyatt? 1. So that's the tangent of 45. And that's what's 1 over root 3. What does that become when you rationalize? Root 3 over 3, we should know that because we've seen it a million times already from doing our homework validly, not copying, and actually doing it. Not half of you who don't do your homework. Blah! I wish they had my face on this video. The new one doesn't have my face up there, so you can't see my expressions. Okay, who was next? Julie, were you next? Yay. Okay, all right. So, you know what's funny? Oh, Julie, what is the tan of pi over 2 when it's sine over cosine? And that's where pi over 2 is. So what's 1 over 0? Undefined. What's the tan of 0 or 2 pi? What's 0 over 1? Oh, 0 over 1, 0 over any number except 0 is 0. Okay, so that's 0, not 1. Who was last? I forgot. Nice. Abby? Ava! Oh my gosh. I have an Abby first hour and I just did an A. Okay, sorry, Ava. Sorry, I threw out an A name. Now we got this one. I'm going to ask you tougher questions like this. Cotan, which is just the flip of tan. So what's the cotan of pi, which would be cosine over sine? Undefined. That's how you play the game. You just flip it around. And that's how this works. For those that still don't know the unit circle, all right? You draw this, you memorize it, and then you know it's cosine comma sine, and then tangent sine over cosine, and vice versa. Ava, sorry. What is the secant of, let's say, pi over 3? I keep saying degrees. Now, secant's the flip of who? Sine or cosine? Cosine. So all I have to do is find cosine and flip it. So what's the answer? 2. That's how you do this. You got it, Tyler? Sure. Teachers always love that answer. Sure. Tyler, what is, I'm going to give you a tough one. What is the cosecant of pi over 4, which is 45 degrees? Okay, so let me hit back button, let you think about that for a minute. No, it's the flip. Who's the flip of cosecant's the flip of who? Flip of sine. What does this become? We actually had this a few times yesterday. What's the flip of root 2 over 2? I know it's now you're struggling here. Someone help him. Unless you, what's the flip of root 2 over 2? Just root 2. You don't want to flip 2 over root 2 and then try to rationalize it. We need to know where that comes from. I'll give you another one. What is the cosecant of 3 pi over 2, which we are accessing this coordinate? Okay, what did I say? Secant or cosecant? Sorry. I said cosecant? Yeah. What's the cosecant of 3 pi over 2, which is this is the coordinate you're accessing? Which one's the sign? 0 or -1? So I just need to flip this. Why would the negative disappear? Yeah, but that's not taking an opposite. Flip doesn't mean opposite. I mean, what you have here for sine is -1 over 1. What's the flip of -1 over 1? Just flip that fraction. What does that become? 1 over -1, which is what? -1 still. Okay, and this is what we need to know what to do here. All right, next. Okay, so I picked on him just because, whatever. What did you say? What did you say that threw me off? Sure. Yes! All right, here we go. I got a tough one. What is the sine? No. What is the cosecant? Did I already do this one? I feel like I might have. No. What is the cosecant of pi? Cosecant of pi. So it's the cosecant. Who's cosecant related to? You're not. Yeah. I say cosecant. Who's related to cosecant? Sine. So you're flipping this. You should know this from graphing. What's the flip of 0? Undefined. So the cosecant of pi is undefined. This is how you use this thing here. So I feel like we need to go back to this because I have so many people that still don't know how to do the unit circle. Uh-oh, we have a question. 0 over 1 flips to 1 over 0. Not equals. Sorry, that's wrong. And that's not equal. Well, that is equals, but whatever. 0 over 1 flips to 1 over 0, which is undefined. We did that when we graphed, and that's how we got asymptotes. That's how it's all related. Are you sleeping over there? Okay. Are you okay back there? Stretching? All right, I guess that's allowed. All right, next. How's that gum over there? Good? Okay. Checking in on the students. I will tell you, on Thursday or Friday, you're going to have an identity quiz. You're going to have to fill this in. Here, you can cheat. Here's the quiz. The quiz is this. You won't have this side. You have to fill in this side. There's the quiz. So when I ask for the reciprocal, what does reciprocal mean? Reciprocal means starts with an F. There's an L in the name. This is why I'm calling you out by, what's the word? Flip. This is the flip identities. There's your quiz. You're going to have to say cosecant is equal to 1 over sine. You're going to have to fill in that blank. This is the one time you actually have the quiz in front of you, and you know what the quiz is going to be. There is no tricks. What I need to make sure is you know how to find, or you know what these are in your head. You have to memorize. It's a job. You have to memorize in every class. We should already know these. That's why I had this up here, right? And that's why I have these green arrows. Sinus, sir. So cosecant is r over y. That's why I have it color coded. And that's what I've been writing every single time I've been doing questions in this class. That's why I need you to be focused and understand. If you just focus and understand and do everything we do in class and don't do your homework, you probably could be okay. All right. But some of you don't do either. All right. And we don't really get access to the notes and really understand. Oh, and by the way, what's sine of theta then? Sine of theta is 1 over, who do I have right now? One more. What's sine of theta then? 1 over, all I'm doing is just an alternative form of this. Cosecant. So you got to be able to work with this both ways. That is true as well. Okay, that's what we have to know. Got it? Got it. Okay, let's get our next students. I'm going to point at you, so we'll keep your names off of the internet as well. 2. Yeah, you were raising your hand over there a lot. Yeah. Uh-huh. Okay, now, so Tanico, one more thing on this, because I do have to get going. Something you should understand about is this. If I have tan squared of theta, then that is equal to sine squared of theta over cosine squared of theta. So that is true. The powers translate. And there's reasons for it. It's math syntax and how things work. And then just playing around with this, cotan to the 4th. I remember I wrote that last hour. The powers translate. That would equal cosine to the 4th over sine to the 4th. I remember that being like, boy, I'm flashing back like even 10 plus years ago. I used to do this calculator thing calling on students. And I remember a student like 10 plus years ago going, wait, if it's tan squared, is that sine squared over cosine squared? Yes. So I'm thinking about that student from way back when. Hey, can we just draw that, right? Can we just draw that? You don't really need that today, but that's why I wanted to do this, because this is where I get mad. All the things that I see about not doing our homework and say, hey, this is what you should do before we're doing a quiz and I walk around and nobody does it. Some don't need it. Some of you don't need this. Some of you know, like, what side of a 30? Say it, everyone. 1/2, and then you use that to find all the 30, 60 sine and cosines. All right, so some of you don't need this. But the 30, 40, and 50 percenters that I have to rack my brain and hit my brain up against the wall grading your test, you need this. And you need to start changing. 3 months of doing this. 3. All right, get it figured out. All right, so here we go. I'm going to write this. I crossed this out on purpose because I want a little different directive here. Is this what you remember as the Pythagorean theorem? A squared plus b squared equals c squared, right? But what I want to do is, and want you to do as well, is make a drawing over here. Student number 2, you're up, right? You didn't really answer anything yet? Okay, remember this? Our first question in the quiz is, right? Yeah, that's right. That's right. Sorry, I thought I did something wrong. The question that we had was 4 comma 6, and then we had to use the Pythagorean theorem. But what I want you to understand is, why does it turn to x, y, and r? Because this is coordinate trig. This is x comma y up here. All of it is coordinate trig. That's why I put these as coordinates up here. Those are coordinates on the unit circle for 30, 45, and 60s. All right. And then, okay. Student number 2, we'll stick with numbers. Keep you off the internet. Whatever you do to one side, say it. There you go. You know what I'm going to decide to do? I can do whatever I want. I can divide both sides by a dead skunk, as long as it's equal weight and size and smell. As long as I do the same thing to both sides, the equation will be balanced. You got it? So what I'm going to do is decide to divide both sides by r squared. Now, student number 2, I'm going to go through this one, all math syntax. And then after this, we're going to not worry about the math syntax. The first thing, student number 2, is this side, division is distributive. So I can split this up into 2 separate fractions. Or this is the opposite of getting a common denominator. You know, you can split those up into 2 separate fractions because they have a common denominator. Second thing, student number 2, you don't have to do anything yet. When I have a fraction squared, or when I have a square over a square, that means the whole fraction squared. Student number 3, are you paying attention? So you guys have water bottle ready, and you were looking out the hall window, looking at the clock. You know, when you look at the clock, it goes faster. That's a lie. All right. Anyway, Dom. Oh, Dom. What's r squared over r squared? Don't you feel alive? Wyatt, how you doing over there? Oh, I mean student number 10. Hey, student number 2. And then I'll leave you alone after this as long as you get this one right. What's x over r? What's x over r? What's x over r? You said Kixer, but then you said secant. No, which one's x over r? Which trig function? Because secant's r over x because of the, that green arrow above it. Huh? Cosine. All right, and then let's get my next student, get him warmed up. 7. Yeah, look at you rubbernecking. All right, I saw you. You're gone. All right, so now where are we at? Okay, so student number 2 said this is cosine. Oh, by the way, I have to put this in here, and we're never going to go this far again. But you know what theta is? It's this. It's this mysterious angle right there. That's what it is. And that's what trig is. It connects angle measures to side measures in a triangle. That's what it does. So I can replace x over r, that ratio, with the cosine of the angle measure in that triangle. That's the rules. Okay, student number 7, what's y over r? Which trig function? It is sine. So we're going to replace that with sine. And then, you know what? For math syntax purposes, they always write it like this. This is what I mean about math syntax. I broke this down in every possible way that a mathematician would be happy with how I wrote everything and all the connections that are true. And there you go, guys. You're going to have this memorized. You're going to have this Pythagorean identity memorized in terms of trig. But I'm going to tell you when you have that quiz on Thursday or Friday, what you can do really fast in order to know what these are. It's very simple. You're not off the hook. But here what we're going to do is we're going to do this one more time. Here's how you create this on Thursday or Friday. You go back to this. Okay, it's x squared plus y squared equals r squared. You do have to have this memorized. And then all you have to do is do this. Student number 7, whatever I do to one side, just do this in order to create this one. Just divide both sides by r squared. And then just do this. I'm going to make you repeat what we've already repeated. What's x over r? What's x over r? Which trig function? Cosine squared. What's y over r? Sine squared. Equals, what's r squared over r squared? 1. You should be able to do this and go right to that right away on Thursday or Friday. And if you can't, I don't know what to do with you. I really don't. All right? I don't. It's so crazy how many people like act like they're so flabbergasted by the questions that are on a quiz. I don't understand. All right, and you know what? You've done well. I want to mix this up a little bit. And by the way, when I do this, you will only have to go twice. So you're not off the hook yet. All right, but if you go a third time, then we'll let you off the hook. You're up. Okay, Europe. I went to Europe. All right. Anyone ever go to Europe? Did you really? Where'd you go? Give me one city, town, place. Ooh, nice. All right. Was it beautiful? Yeah, it sounds like it. Here's how you get another one. Whatever I do to one side, say it. What? You got to speak up. All right. And then you know what we're going to do now? We're not going to divide by r squared. We're going to divide by, I'll give you an easier one because at least they show up in one of our Sir Kicks or Tixes. Okay, first things first, what's x squared over x squared? So it's 1. Now, this is what I mean about in our little thing there. What's y over x? Which trig function is that? Tan. You got to speak up. I can barely hear you. Speech class. Remember, I took a speech class in college for the first time. I was terrified. I hated it. But then I actually found out I was not bad at it. And then kind of naturally progressed to being a teacher. And then what's r over x? Stop. What's r over x? This is why I told you this is the main thing for the day with our identities. What's r over x? Huh? Yeah, trying to get you to speak up. Good. It's secant. Because cosine's x over r, secant's r over x. So if you know those, this is simple. And then that's another trig identity. Secant squared of theta. Let's get another one. Tired of this. 6, that's a new one. 1, 2, 3, 4, 5. Ooh. Okay, so then you know what, whatever I do to one side, say it, because everyone's had to do this. Huh? What? There you go. Yell at me like you're mad. And then what do you think I'm going to divide by? What's the only thing I haven't divided by? Dead skunk? What? No. What'd you say? Y squared. Okay, now this gets a little bit tougher. What's x over y? Yes, cotan. It's not tan, it's cotan. And then what's y squared over y squared? And then what's r over y? What's r over y? Yeah, and you're looking at that Sir Kicks or Ticks. This is why I told you to write this down on every test because it comes up. And there you go. There's a third trig identity. So what am I saying? On Thursday or Friday, when you have your quiz, I should see this 3 times. Or what I do real quick is this, right? And I'm probably spending too much time on this. But I write it once, and then I do this. Ready? This is what I mean about paying attention. The first thing I do is divide by r squared. Okay, everyone, this is why we're on the individual, because no one ever answers everyone. What's x over r? 3, 2, 1, go. See, there you go, nothing. Crickets. Click, 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 click. What's x over r? Cosine. What's y over r? Sine. What's r over r? 1. And then I'm done. And then I divide by x squared. What's x over x? 1. What's y? He still hasn't answered. Go ahead, take a drink, because you're not using your mouth to answer any of these questions anyway. Put that bottle in your mouth right now. Let's go. Drink. Drink. Let's go. Since you're not answering questions, go ahead and drink that bottle right now. Get it open. Here, I'll open it for you. You haven't used your mouth one time. Not once. Oh my goodness, teaching in America. Sitting there, listening to everyone else answer. You're just looking out the window. All right, what's x over x, everyone? 1. What's y over x, everyone? Tangent. What's r over x, everyone? Okay, you take a minute and that's secant. Then get rid of it, and then you see what I'm saying? You don't even have to write it 3 times. You divide by the individual letters, then get rid of them and divide by another one. You got it over there, water guy? Okay, good. Oh, by the way, what you should also be aware of is, one more time, whatever you do to one side, say it, do to the other, alternative forms of these same formulas. So what I've shown you is how to derive them, but then all you have to do is rebalance this in different ways. So what's sine squared equal to? I'm going to get somebody, because you did pretty good there. You're done. Can't hit the calculator here. Enter. Ooh. Is that you again? Yes, this is your second and last time. Okay, so what's sine squared equal to? What do you think I did with cosine squared to get it over here? What operation? Yeah, there you go. So what's sine squared equal to? Okay, I'll take it. Plus 1. Usually we write it like this, though. She said negative cosine squared plus 1, which is totally correct. I just want to write it how you're normally going to see it. And then wouldn't that mean cosine squared equals 1 minus sine squared, right? If I decided to subtract there. But what is negative cosine squared equal to? Now that's a tougher question. So if I subtracted, that'd be 1 minus sine squared. But then negative, that means I'd have to distribute a negative to the other side, and then that would be the case. So imagine subtracting sine squared, but then multiplying both sides by a negative. So I could do this all day. I could reshuffle this in so many different ways. But I will say, what is your job when we actually use this stuff? The job is actually anyone? Substitute? We're getting a substitute because we're sick of Mr. Samuelis? No, substitution. How you doing over there? Good? I can't wait till your number comes up. All right, here we go. You did a good job. I'm gonna call it a day on that one. 12 seems like a repeat. Is that you? No way. Are you ready? Oh, you got the worst ones. Okay, so let me do some other ones. Let me do this. Like, what's 1 equal to then? What do I have to do to get 1 equal here? What would I have to do to both sides? Okay, so tell me what I would have? Well, don't forget about the squareds, right? And that does worry me that not that you would do it, but people do this. This doesn't mean like sine plus cosine equals 1. That's not true. It's got to be squareds. All right. And then one more over here. Hey, you're on fire here. So what's 1 equal? I like getting what 1 equals. But the problem with this is you do need to just know the originals and then be able to adjust. That's all I could say here. I could keep doing this. I could keep going. -1 equals the flip. So this would be positive and this would be negative. That's just distributing a negative. I could do this all day long. I could write alternative forms of the original. And you just got to be ready for any of those forms. And now, but that's a little too easy. I'm going to have you do this first one. We're going to use trig identities to write each expression in terms of a single trig identity. Now, fractions. We're in trouble now. I've been trying to teach fractions all year long. Now you're doomed. Okay, if you don't know how to deal with a fraction, you're done. Because here's the number one thing that you want to do in order to simplify. You want these all in the same variable. And I'm using air quotes because you can't see my face right now. What I mean by that is we want to get things that are in the same trig function so we can see if anything cancels. So I'll direct you, student number 12, right? What is tangent in terms of sine and cosine? So what is that? And all you have to do is maybe flip your paper because you don't have it memorized, possibly, even though we should have it memorized. Huh? Sine over cosine. Now, this is where people get really silly. And I'm going to write this. Do not write this. But isn't cosine 1 over sec? Do not write this. Isn't this true? Yes or no? True or false? True. Does that help anything? No, you've just changed the variables. I'm trying to get tan in terms of sine and cosine. You did a change that's true, but completely and totally nonsensical. All right? It doesn't do anything for our simplification. So we're going to leave this as cosine. And then student number 12, what do I do? What happens next? In multiplying fractions, what can I do? Dang it. All of first hour said cross multiply as well. That is not true. It's cross and it starts with a C, the other word. Cross, can, cross can. I can. Lockport. Drink. Glug, glug, glug. I hear people saying it. This is getting the cross cancel. Cross multiply is when you have an equation and you solve. And I don't know what I can do to get you to understand this. This is fractions 101. This is 4th grade, 5th grade fraction work right here. Not really with the cosines, but the idea. All right. So therefore, this turns into sine. And then student number 12, don't you agree that this is smaller than the original? Simplified less terms. And that's what it is. This is a huge concept in calculus. And we are supposed to be pre-calc. We're supposed to be preparing you for that class. So on and so on and so forth. Hey, we literally wrote this on the other page, student number 1. Don't let anyone tell you any different. You're number 1. Huh? What is 1 minus cosine squared? If you actually wrote your notes, you'd have this written down. What's 1 minus cosine squared? Oops. It's 1 minus cosine squared. Huh? Oh, dear Lord. All right, here we go. I'm sorry, I got to do it. What's 1 minus cosine squared? We caught a non-note taker. What's 1 minus cosine squared? Sine squared. We caught a non-note taker. And I can't move my screen anymore. There we go. So 1 minus cosine squared is sine squared over cosine squared. Okay? And what we're doing is simplify. Okay, so I do have to call this out. Whenever you have squareds, maybe do a Pythagorean identity. Don't do like a sine, change everything in terms of sine and cosine, although these are in terms of cosine. All right? And then what's sine squared over cosine squared? We literally have this written on the notes as well. Tan what? There you go. And I made a point of that. That's why we literally have this written down. You know, when it's sine squared over cosine squared, it is tan squared. Okay, I got to move a little faster here. All right, okay, here we go. This is going to be interesting. Student number 7. That feels like a repeat. Is that you? Okay, 7. What's sine squared plus cosine squared? That is 1. And that's what we're going to do. This is why we can simplify this. And then, you know what? I do want this. I want this fast. The other teachers may not. If I have a secant on the bottom, what does that mean I can write on the top? Yeah. What'd you say? Sweet Georgia Brown. That is awesome. And that's how I want this. I don't want what other teachers might want, like changing this to 1 over cosine, and then 1 over cosine is cosine on the top. I want you to be able to toggle this super fast. And I'm going back up to here, like this. Hey, a cosecant on the bottom is a sine on the top. A cosine on the bottom is a secant on the top. I want you to be able to go that fast. Got it? Okay? A cosecant, like a cotan on the top, is equal to a tan on the bottom. I want you to go that fast with these. I don't want you to write cotan as 1 over tan and then flip it. And I want you to toggle up, down. And I think that's perfectly legal with your math there. Last but not least, what's cosine over sine? Starts with a C. I'm going to trick him. CO. There you go. Don't you feel alive? If you have to keep flipping your paper, though, you got to get this locked in. So we hopefully get those locked in pretty quick. Okay, so this is numero uno. What we just did. Most of the times that occurred, and that usually is the case. But put a star here. Whenever I see squared trig, check for a Pythagorean identity instead. Got it? That's what you really want to do in order to do the simplification, so on and so forth. Okay, I got to speed up. I noticed the time there. All right, let's get somebody else. Come on, come on, come on, come on, come on. There we go. Boom, boom. 6. Nice. Your second time. Here's what I'm saying. Leave the sign alone. And then tell me, where does this cosecant on the bottom, what can I write and where? Yeah, we kind of just went through this. Sign on the top. And actually, I should, let's color code. Let's be real fancy with this. This means I could write a sign on the top. And then let's get another color. What does secant squared become? What can I write and where? So I have a secant squared on the top. What can I do now? Cosine squared on the bottom. So I can write a cosine squared. Now, the other teachers may hate me. Well, they already do hate me. I don't care. Used to see me in math meetings. I got called a jerk once. Can you believe that? Me, of all people? Anyway, it's a true story. I don't care what they say. This is true. If I have a secant squared on the top, that means a cosine squared on the bottom. If I have a cosecant on the bottom, that means a sine's on the top. That you're doing the flipping. You're already doing it. And then student number, 6, I think. What's sine times sine? I don't want to assume anything. And then what's sine squared over cosine squared? Tan. There you go. And there, you have to admit that that's way more simplified than the beginning. Okay, we did logical substitutions, equivalent substitutions, and ended up getting that. All right, next. Now you can relax. 4 is new. 1, 2, 3. Nice. Went to Warsaw, right? That student. Hey, what's cosecant become? Huh? No, Wyatt, you're not up. I'm going to use your name again. Foul! Out of order, sir. Out of order. Sine on the bottom, so 1 over sine. And then what's tangent? I know it's 1 over cotan, but that's useless. That doesn't do anything. Oh, no. Oh, yeah, it is. I'm sorry. I said cotan and I got myself screwed up there. It is sine over cosine. And then tell me what happens. Cross cancel. You are correct, not cross multiply. Everyone made that mistake up to this point until we covered it. Hey, then what's 1 over cosine? Which you could have skipped this step and wrote the final answer. Secant. It's just a little game. It's a substitution game that we're going to be going over. And by the way, take a deep breath. We are going to take a few days on this. This is going to be used a few days because this is a hard little section. And then this one gets really tough. Because this is kind of an outside the box kind of thing for you guys. Student number 3, nice. Hey! All right, here we go. What's tangents? You got it? And your writing has to be perfect on this, not to bring this up particular with the student that I just called on. If I can't read your writing, you will get absolutely no credit on these questions. It's all about the work. All right? And then you know what? Sine's 1 over cosecant, but that's useless. Here's what's useful. Understand that sine is sine over 1. That means the numerators would multiply. Again, this is fractions 101. It makes me sad I have to cover this for how bad we are with fractions. All right? But that is the truth. So this will become sine squared. Just think about that. And then over here, this is cosine of x over 1. Oh, I get some stupid stuff like this. Can I cross cancel across a plus sign? No. And I did use the word stupid. Sorry, I shouldn't have said that. Really not intelligent. No, I'm just kidding. That's not good either. That is really bad in fractions. All right? You can never cross cancel across plus. Hey, but whenever I'm adding fractions, student number 3, what do you get in grade school? A common denominator. And why do I like this? What is the common denominator? What is the common denominator? Cosine. So what do I have to multiply top and bottom by? This fraction. Say it again. Cosine. And why I like this is I'm already reading the future. And I get it. This is going to be sine squared. And now I created plus cosine squared. What's sine squared plus cosine squared? It is. But don't skip that step. You have to show it. You have to show that this occurred. And then the whole point of getting a common denominator is to carry them over a common denominator. All right, and this always makes me mad when students get thrown off by that. What's 2/3 plus 5? What's the common denominator of this little basic grade school fraction? 3. So what do I have to multiply top and bottom by over here? 3. It's the same concept except it's trig. Who cares? All right, and then what does this end up becoming? 2 plus 15 all over a common 3. Don't you carry the common denominator when you're adding fractions? I'm just trying to show you why this turns into 1 cosine on the bottom. All right, and then of course that's 17/3. But you know, this is why the stuff we're doing relates to 4th, 5th grade math, and you need to trick yourself in order to understand that. You already told me this. What's 1 over cosine? Last thing I need you to do. Oh, it's the other one. 1 over cosine. Secant. Okay, and then that's most certainly more simplified. Okay, all right, so I'm running short on time, but I am going to go over this real quick. Which of the following are not equivalent to cotan? Hey, everyone, what's cosine over sine? Say the thing. What's cosine over sine? Cotan. So it's not that one. Hey, secant on the top becomes what on the bottom? Secant on the top becomes what on the bottom? Cosine. Hey, let me change colors. Cosecant on the bottom becomes what on the top? Sine. What's sine over cosine? Tangent. It's this one that's not. Okay, then go ahead and put your stuff away. I'm going to finish my video, though, because what I'm going to do is prove that the other ones are cotan. Okay, why? Well, here we go. I wish I had more time for this. I don't remember my Pythagorean identities, so I'm going to write my Pythagorean theorem down real quick, because this is what I'm going to have to do when I have to spit back the identities. And then how do I get cosecant? That's r over y. So this is cotangent squared beta plus 1 equals, got that phone out, r over y cosecant squared of beta. And then if I just subtract 1, and then those that are still listening, how do I get rid of square roots? Oh, sorry. How do I get rid of square, which I just told you the answer? Square rooting. So, hey, that is equal to cotan. That's wild. And then the last one is supposed to equal cotan. Let me just double check. This is 1 over sine. This is 1 over cosine. That's weird. This is getting strange. Minus, then this is sine over cosine. Hey, whenever I subtract fractions, what do we usually get? What do we usually get? Whoever's still listening. Common denominator. See you guys later. Do your homework. We're going to collect it. Be ready. I'm going to go ahead and finish this off. Hey, what's 1 minus sine squared? And then the whole point of a common denominator is write it as a single. This becomes cosine. Look at this. Cosine squared. That's a Pythagorean identity replacement. See ya. And then that cancels with one of those. And then lo and behold, cosine over sine is cotan. So I proved that that one actually equals that as well. All right. Hopefully this video works.